You know, literally for centuries, for thousands of years, man has pursued the fountain of youth. You know, the dream of being young for a long, long time, or forever in some cases. We've had the Egyptians. We had Ponce de Leon. And what's so incredible about science is that we haven't stopped moving forward. More has been done in the field of anti-aging literally within the last 10 or 15 years than in the history of mankind, even to the point where we've actually discovered the clock that causes aging. However, I want to take you a trip back in history and let you know how they were able to come across this incredible breakthrough. There was a woman by the name of Henrietta Lacks who died in 1951 at Johns Hopkins in Baltimore of cervical cancer. And they did a biopsy on her cells. Well, 61 years later, those cells, not only are they still alive, but they continue to reproduce. And they're responsible for some of the biggest breakthroughs in the history of medicine, things like the polio vaccine and many of the wonder drugs. And it was through studying her cells that they realized basically these are immortal cells. Because not only are they reproducing, but they're thriving. They're actually keeping their youthful functions over the course of 61 years. So in looking at these cells, what they developed was they found that in all of the human body, we've got about 100 trillion cells. Each cell is a nucleus, and the nucleus is made up of your DNA, or your chromosomes. There's 23 from the man and 23 from the woman. And in each of those chromosomes is contained your DNA. If we thought about a woman's necklace, like a pearl necklace that you would wear, each bead would represent a piece of DNA, and each of those chromosomes, if you stretched them out straight, would have 100 million beads of DNA. But here's what's amazing. What they discovered was that it's only the last 15,000 of those 100 million beads that determine aging. Those are called telomeres. And what telomeres are, they're kind of like the shoelace, the eyelet at the end of your shoelace that protects the rest of the shoelace. They do the same thing. But unfortunately, starting at conception, you have about 15,000 of the telomeres of these protective coatings. But by the time you're born, you've already lost 5,000. That's a third of your total telomeres. Now, what happens is every time a cell reproduces, and in a human being, since I've been talking for about a minute or so, I've already remade 1 billion cells. We remake about 1 billion cells a minute. And as those cells are remade, the telomeres begin to shorten. And over the course of a lifetime, you can only lose about 5,000. Once you get down to 5,000, your cells can no longer replicate, and you die. Well, so if you wanted to live to be 100, thinking at birth you started with 10,000, you could lose about 50 a year for 100 years. That would mean at the end of 100 years, you'd be down to 5,000, you wouldn't live any longer. Now, what did they discover? Well, that was the clock. But there had to be something. Why at conception, all of a sudden, did the telomeres begin to shorten? Well, there was the mystery unraveled. What they actually discovered, a friend of mine by the name of Dr. William Andrews, discovered in human beings an enzyme called telomerase. And what does telomerase do? It protects the telomeres from shortening. Now, we're a long way from living to be 200 or anything like that. But what we do believe is that we're very, very close to supporting telomeres in such a way that you definitely could live healthier longer. Now, let me explain a little more in detail. If you thought of a rheostat, like, in the lights in the studio, if we turn the rheostat down, the room would go completely dark. Well, at conception, that rheostat gets turned off, that enzyme called telomerase. Now, what does telomerase do? Well, basically what it can do, instead of losing 50 telomeres a year, it could potentially slow it down to the point where you'd maybe lose 45 or 40. Well, if you multiply that out, that has a huge impact on your life. But also, not only would you live longer, but you'd live healthier. So the idea is there anything, is there a mechanism, is there some reason? Can we turn telomerase on? Well, science has said this already, that vitamin D3 and omegas are major contributing factors to supporting telomeres. What does that mean? It means potentially they're going to help to slow down that process. So guess what? The fourth pillar of health is what? Called Ageless Essentials, which not only contain the highest quality, high concentrations of vitamin D3, but also omegas and something called CoQ10. Now, CoQ10, some of you may have heard, it's very, very good for the heart. It definitely deals with inflammation, but more importantly, it's an extremely powerful antioxidant. Now, you know about antioxidants, they attack free radicals. Well, believe it or not, when you go through the cleansing process in the body, we do create high levels of free radicals. Well, CoQ10 can help to deal with that. So again, remember I talked about a nutritional technology. So it's not just that you're taking omegas, it's not just that you're taking vitamin D3, but you're also taking the vitamin D3 to assist the body as you're going through this process of hopefully living healthier longer. But keep in mind, the main job here, the main job is, can we do more to support the telomerase enzyme? And that's what I'm going to talk about next when I talk about Pillar 5. Let me warn you. I want you, when you listen to this, to look at the time, look at the date, and remember where you're sitting. Because what I'm going to share with you absolutely, positively will look like science fiction to you, only it's not. Because I've been to the lab, I've seen the research, I've met the scientists. We are on the brink of something that mankind is going to be so celebrating. Probably, arguably, the greatest discovery in the history of man on this planet.